Hi everyone, let's continue with sample exam 3, question 16 in Chem 11. This is a question about thermochemistry, specifically about expansion work, the type of work that we see in chemical reactions. And so the question asks about which of the following reactions does expansion work on the surroundings. And so just a quick reminder about expansion work. The idea of it is that if you have a reaction, let's say with a movable piston, and you have some reactants in here, and then the reaction happens, there's two possible results that you can see. One is that the volume of the container increases compared to what you started with. That's what we refer to as an expansion. And then it's also possible that you get a decrease in volume compared to what you started with. And so that's what we call a compression. And whether you have expansion or compression, you use the same equation to calculate the quantity of work. Work, remember, is force applied to move something a certain distance away. And in terms of work expansion, that equation becomes negative P external, which is the external pressure that's the gases is pushing up against or being pushed by, times the change in volume that occurs between the initial and the final states of the system. And so you can see that the question here is asking about which of the reaction is doing expansion work. So if it's doing expansion work, that means we want to see an increase in volume at the end of the reaction. Now, you can get an increase in volume. In other words, your final volume is bigger than your initial volume if you have more gas at the end of the reaction. So in other words, on this side, you have to have more gas particles. On this side, you have to have fewer gas in order to see an expansion. And that's really how we're going to analyze this question. We're going to look at each reaction and determine whether there's more or fewer gas between initial and final. So let's take a look at reaction 1. This is a reaction between a conversion of nitrogen gas to nitrogen liquid. So you have less gas as you go from reactant to product. You have gas in the reactant, you have no gas in the product. So that means that in this case, you will not have expansion. In fact, in this one, you're going to have a compression. Let's take a look at the second reaction. Here you have two gases in the reactant. In the product, you also have two gases. We need to make sure that the equation is balanced, and in this case, they are, and all the equations are balanced, but that's important to check for. So in this case, we have the same number of gases on both sides of the equation, so we actually have no change in this case, so no expansion or compression. Let's take a look at this third one. We have a solid and a liquid, so no gas. And then on the product side, we have a solid and a gas. So therefore, we have something that starts with no gas to something that has gas. So the volume is now going to increase. So there is an expansion for this one. So that's our first choice that's correct. Let's take a look at the fourth one. We have a liquid and a gas, three gas in this case. And then on the product side, we have a gas and a liquid. So let's take a look at the actual number of moles of gas. So here we have 3, here we have 2. So that means you're actually decreasing in number of moles of gas. So then this one is a compression. And then the last one, solid becomes gas. So we have no gas, we have more gas after the reaction. So that's also an expansion. And that's also one where work is going to be done by the system. So we have two reactions in this case, C and E, or number 3 and number 5, where expansion work is being done by the system.